So I'll try to explain what I actually did. Uh, yeah. Uh, so the name of the game is Stealth Command. So the idea is uh, whenever a player joins this game, they take over a city, and they are in charge of defending the city, and they build a defensive army to defend the city. First, a little bit of background. A similar project was actually built in last month's hackathon at ETH Global's Circuit Breaker. So where I use ZK for this game. And in this game, I wanted to use something different. I came across fully homomorphic encryption. So I built this with FHEs. And this project is actually like less of a game, but more of exploration into how ZK measures up with FHE and what is better and what is not. Um, so let's talk about so the game. So the defensive army is private. So only the person who sets it up knows about it, and they have a proof of it on chain, and no one knows about it. And the attacks on these defensive armies are public. And then as the history builds up, then you can guess what the defensive army can be over time, and that's the premise of it. Um, so how did it work in ZK first? Before I understand how it works in FHE. So in ZK, player one comes in. He built. Oh, is that better? Okay. So how does it work in ZK? So in ZK, let's say player one, who is a defender, comes in and makes a proof of his army that his army is not overpowered. It follows all the game rules, and then he verifies that proof on chain, and on EVM smart contract you just verify it, and you just only store the hash of that verification, or hash of the defense. And then in step two, player two comes in and attacks the city, which is public, right? And this attack, everyone can see what happens. Then in step three, player one has to come back and actually make this off-chain computation of the battle, because he is the only person who has the defensive army. The what's the makeup of his defensive army, and the attack is public. So he takes his private stuff, makes a battle proof of the off-chain computation, and then verifies it, and then the battle result it goes on chain. This is not only does it help with privacy, but it also helps with um, scalability. So you can have a massive computationally expensive battles that can happen off chain, and all you have to do is verify it, and that's about it. Um, but then what happens if player one doesn't do it? Like, because he sees the public attack, and then he's like, okay, I'm gonna lose anyway, so I'm not gonna do this, and then he ghosts. Then player two can come back after 24 hours and just win. He can just loot the city. So that's how I did it in ZK. Now FHE makes it a lot easier. So with FHE, they have something called ciphertext, which is the encrypted version of anything that basically, yeah, it's encrypted version of data. So you can generate a ciphertext, and then there is a TFHE library. It's Torus over fully homomorphic encryption. That's what it stands for. I am a developer. I don't know the details. Not a mathematician. I'm just called the API. It works. Uh, so you generate the ciphertext, and this verification happens natively. Like it's like you as a developer, you don't even think about it. You just say like just encrypt it, and it does it. And you can encrypt the entire data on chain. And then when the public attack happens this time, I don't have to wait for this player one to come back and do the proof verification, because the really cool thing about fully homomorphic encryption is you can do mathematical computation on the encrypted data itself. Um, so you can just calculate the data and everything, and the result just happens one two step, just like you would think in a smart contract would happen. So yeah, so that's what I found in this game. Advantages of fully homomorphic encryption is basically makes the developer experience and the user experience a lot easier. But does that mean fully homomorphic encryption is can replace ZK? No. While FHE could be cool at privacy preserving stuff, ZK is still the king of off-chain computation verification. So this is the meme I came up with. Like you make off-chain game, yeah, on-chain game, okay, and then on-chain game with ZK is a little better, but then you can combine the two to make it really better. I really don't have anything other than like unit tests that I ran to make sure that everything is running properly, and yeah, that's about it.
Thank you so much. Any questions about Saurav's project? Yeah, Daniel.
I have a question that maybe is a bit to complicate your game. It's maybe it can be done, cannot be done, but imagine that you can have a partial decryption of the secret in the sense of the player through advances and then see some troops, so they get some part of the, I would say, a battle order of the player one, and then discovers which kind of troops he has and parts partially, so decrypts or like gets some part of the secret revealed but not full, and then he can decide. I don't know if this can be done with the type of encryption and mathematical cryptographic process you have, but this could be way one way to complicate the game, but also could be a way to also reveal secrets partially in the sense of, because again here we have a binary discovery of the secret. It's like you have a full order battle versus full order battle, but I mean troops advance and then they can start to see things or rather start to detect troops. So could be this maybe it's a goal that you can try to play with it if you can have this maybe chunking the secrets in different partial order battles, I would say, and then complicate the game with this mechanic. I don't know. This like just came into my mind. I have played games a lot, so maybe this guy comes from here.
Yeah, maybe you guys can chat after and come up with cool ideas that Saurav can implement. Do you want to comment on what Daniel? Yeah.
So yeah, I mean that with this encryption, I mean basically I have the ability to encrypt whatever data I want and leak information as I see fit. So basically it would be like a more complicated smart contract, but this can be done. And really cool thing about FHEs, so yeah, so I forgot to tell you the two things I did work on. The two networks are Phoenix and Inco. They are pretty similar to each other, and they're both built on something called Zama. Zama is I don't know, it's probably a Swiss team, and or it's probably built out of France. It's a European team. That's all I know, and they are not interested in blockchains. They just want to do cool math stuff, and then these two companies are building on top of them. And one cool thing that they let you is called fully decrypt or decrypt for a one person. So this is not just for auto battler, but you can think of it as making a poker game. So you can actually decrypt for one person. Only one person can see their card, or you can decrypt it for the entire world. So partial decryption, and also the data, what part you encrypt and what part you decrypt is totally up to you, and it becomes a lot easier. But I guess uh, the problem that they are facing right now, which probably would be solved later, is encryption and decryption is kind of computationally intensive process. So now their TPS may not be as high, which I I guess they're gonna try and solve.
Yeah. Question. More questions? Yeah.
What do you think about battleships as a game and like using the logic? Because that makes, yeah, I'm just thinking out loud here.
Yep.
Yeah, Battleship is actually one of their example games. If you go look in the if you go to the Inco protocol, like their website, that's an example they use. It's yeah, it's they show it how easier it is against ZK, I guess. So it becomes a lot easier. So problem with ZK is the off-chain storage. So that's in this case, you do not have to store anything off chain. You can store everything on chain. I I guess it depends on whatever you. I mean, you don't need two chains for ZK, right? Yeah, so sometimes if you need some data to, like, for my game, for defensive army, you have to still store it somewhere so you don't forget about it. So the off-chain data, you're storing it in a centralized server somewhere. That kind of defeats the purpose. So
One more question for Saurav, and then if there's more, you can chat to him after. One more question. Okay, cool. Give it up for Saurav. Thank you so much for presenting.